Hello, this is K.Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering. So today we are going to discuss about how Fourier transforms used in image transformation. First we will discuss what is Fourier transform. So Fourier transform are essential tools in image processing and computer vision. They convert an image into the spatial domain to the frequency domain and make it easier to analyze, filter and compress image. So the Fourier transform decomposes an image into sine and cosine components, revealing the frequency, rate and phase of the images. So the main steps in using Fourier transform is transform to frequency domain. Apply Fourier transform. Example, using fast Fourier transform FFT to convert images from spatial to frequency domain, and in frequency domain modify specific frequency components, that is the example for attenuate noise or enhance edges, and transform back to spatial domain. Apply the inverse Fourier transform to convert the processed frequency data back into the spatial domain. So the main concepts in Fourier transform for images is spatial domain. So this is the original image where the pixel values represent spatial information, and frequency domain. After applying the Fourier transform, the image is represented by its frequency components. And frequency domain representations are low frequencies represent smooth regions, that is gradual intensity changes, and high frequencies represents a sharp transition. And visualization, the magnitude spectrum shows the strength of a frequency components. The phase spectrum contains information about the spatial structure of the image. So the image, next one is image filtering. So noise reduction, edge enhancement are the main application of Fourier transform in computer vision. So by transforming an image into frequency domain, high frequency noise can be isolated and removed using a low pass filter. And image enhancement, high pass filters enhances edges and fine details by amplifying high frequency components. And patterns or features like repetitive textures are most distinct in the frequency domain. The Fourier transform helps extract these features for tasks like texture analysis or in fingerprint recognition. So the image compression in frequency. In image compression, the Fourier transform identifies and reduces the redundancies. In an image. The JPEG compression, for example, uses the discrete cosine transform related techniques to separate images data into frequency components. So in frequency based compression methods, the Fourier transform is used to identify and retain significant low frequency components while discarding less noticeable high frequency data. And pattern recognition and image recognition. The first one is image registration. So aligning image involves finding the spatial information that relates to images. The Fourier transform is used in phase correlation techniques to compute translation, rotation and scaling between images. And pattern recognition. So the Fourier description derived from the Fourier transform of an image object's boundary help in object recognition tasks. So they represent shape information in the frequency domain, making it easier to compare and recognize objects regardless of rotation, transition or scaling. That is, invariance to translation, rotation and scaling can be achieved using Fourier milling transform. These are the critical for recognizing objects under different orientation and scales. And the next one is image reconstruction and texture analysis. So image reconstruction, Fourier transform are instrumental in reconstructing the image in fields like medical imaging, that is MRIs, CT scans and astronomy. So these methods collect the data in the frequency domain and reconstruct the image in the spatial domain. And image matching also used is one of the main application of Fourier transform. So in image matching, Fourier transform facilitates matching images or templates by comparing their frequency domain representations, often reducing the impact of spatial misalignment. And texture analysis or frequency analysis. So identifying textures or periodic patterns is easier in the frequency domain. The power spectrum from the Fourier transform reveals domain frequencies and orientations. And The texture analysis have specific frequency characteristics, making Fourier analysis ideal for texture identification and classification. By analyzing the frequency spectrum, textures can be differentiated based on their unique frequency signals, so aiding in the applications like defect detection, material classification, and remote sensing. So these are the so in this video we learned about what is Fourier transform, what are the process involved, how it is useful in image processing, and what are the main applications of Fourier transform. Hope this video will help you to understand this basics. Thank you.